Hi, I'm Mark O'Pry. I'm with the Analyzer Group, and welcome to the BTU Improvement Project. So our BTU analyzer, since I've been here, has been slugged twice with liquid, and the analyzer can't handle it at all. It flakes out, and we don't get it back. It takes a long time to recover for it. It's got small, tiny capillaries in it and everything like that that can't handle moisture. It can't handle pluggage of any kind, a desiccant of any kind, anything. So I initiated a project to put a sample system on it to eliminate the moisture the best way we could, and in the event it overwhelms it with moisture during a flaring event, that it will do a blowback on the sample line and just feed tiny amounts of nitrogen to the analyzer to keep it nice and dry and happy and safe. So I took a look at some old sample system drawings that I've had from other places, and I based this entire thing off of the INEOS Battleground flare sample system. So it worked really, really well over there. I think it's going to work positively good over here. Let's see. So what we're going to do is, first thing we want to do is just eliminate any and all moisture as we can. So we're going to use a coalescing filter with a membrane inside of it, where the sample will actually, the analyzer is a vacuum. It's pulling a vacuum to pull the sample through the analyzer with a vacuum. It's using an aspirator slash eductor, or whatever you want to call it. They're the same thing. So we are going to be pulling a vacuum through here. I got an eductor slash aspirator, whatever you want to call it, right here, and that is basically the analyzer. That is we'll call that the analyzer. Everything else we used scrap stuff from the shop. This did not cost us anything. We just grabbed parts that we had here, and it came together pretty well. My tubing's not the prettiest, but it works. All parts that we have here, we didn't spend any money on this project whatsoever, so other than time. And we came up with a very, very, very good sample system for it. Basically put everything on this panel, tubed it up. Everything is from spare everything here. Even our scrap pile of tubing is where the tubing came from. So let's take a look at our sample system. I've made a crude drawing of it before we get started here. Here is the crude drawing of it, and I'm gonna have to figure out some kind of get into the computer and figure out how to do this in AutoCAD, or some easy way of doing AutoCAD. But that is my crude drawing. I had crayons to do that. Sample will come in here. So we're gonna have to cut the 1/4" line right there. It's actually a 3/8 that's coming over, and then it goes to 1/4. We're gonna tap in right there. Sample line will come in. We're gonna bring it in directly here. We plan on mounting this either to the building or the stand that I put together. I got out of scrap everything also and made a plate for the bottom, but depending on how they want to do it, I would imagine we would want to mount it to the wall of the analyzer building, and then we're going to need to pick up 120 volts. There's already 4 empty breakers over there, so we can grab the 120, no problem, super easy. I made everything so that it's all, bam, all one thing here, and we just mount it, bring over 120, and bring nitrogen. We're not going to use instrument air, we're going to use nitrogen for everything on here. All right, so as the sample comes in, you'll come down, go through the 3-way. When we're in the green mode right here, green is for go, which means we are reading our sample. Sample will come in, go up, down into our coalescing filter. It's a genie membrane. The sample swirls around in here and then goes down with liquids going down, down, down. And then we'll pull the vapor through the membrane and out the back. Once it comes out the back, it will come over to our water slip relay. I'm unplugged right now, so I'm not gonna have any 120 volts on this thing right this second, but the sample will come in. Any liquids that make it past the membrane would build up on the water slip relay. Those little electrodes right there, as soon as water builds up on those, the water is the switch. And that will fire the relay that is mounted in the back, go through the coil, suck the relay in. Once the relay is sucked in, that will allow voltage to go to this solenoid. This solenoid will then initiate this pneumatic fire, which will do this valve, which opens this up for blowback, and that comes up and comes in right here on the flare sample line, and that will go back up to the probe, blow back into the probe. So there is 60 psi nitrogen sitting right here waiting to do a blowback. The other part, whenever it does the pneumatic fire, it tees right here, comes up to our three-way. Our three-way swaps over and allows this trickle of nitrogen. I installed a regulator. It's behind the panel. The regulator knob is here to set this to 1 psi, and we will make sure that we have no real massive pressure going to our analyzer and hurting it in any way, shape, or form. And so we're just going to trickle nitrogen to the analyzer to make it be super happy while all this is going on. Water slip relay, that's going to be 120 volts, and I put a sticker on the box letting everybody know it's 120 volts. But the only people that will ever touch this is going to be the analyzer people, and they should know exactly what, this is going on here. So we're going to install this back in. It does that right there. The liquid drainer out the bottom, and I put a vent right here so that it could easily go down into the catch pot. The catch pot can be removed. Take the catch pot away after a flaring event and take it back, dump it, bring it back over, or you can replace it with another catch pot. However we want to do it, that's up to the analyzer group. But we've got block valves for it. And again, this water seal will seal off, the liquid drainer will seal off, whenever it's not full. So you're never going to be sucking air up through any of this stuff. If you want to watch the BB in there, see, you know that we don't have any leaks because the rotometer going down. All right. Now we should never ever see this much liquid happen. This is our aspirator right here, by the way. This is our aspirator and pulling our sample into the analyzer. That's a lot of liquid. That is a massive amount of liquid for the sample system. You see the BB dropping? Because the level is up to here right now. We are coming out of that tubing right there, which means the liquid drainer is full. And the BB is back up and running. So basically the sample system handled that no problem. We weren't able to saturate the system to the point where it was going to go through the Genie membrane and liquid actually make it over to the analyzer. So it would stay running this entire time, even with that big of a slug. So let's try slugging it again. I added some tubing to our length on the liquid drainer here. It only needed to go probably to about right here in the liquid drainer, but I'm a little higher, which isn't going to hurt anything. So let's slug it again. See what happens. Notice our BB dropped off, and now our BB is back. And you hear it gurgling. Sample system can handle quite a bit of liquid. The sample system is doing its job. We're not going to have this instance happen on the flare anymore, just with the sample system without all the blowback and everything like that. But let's go ahead and, since we put it in, let's say the membrane gets a hole in it somehow or another through wear and tear over time, and we want to initiate an actual water making it past the Genie and tripping us. So I got rubber gloves on underneath my regular gloves. We're going to want to take water and we're going to want to pull the relay and dip it in the water. Now remember, this is, this has voltage. We are doing blowback, and you see we're on red now. The red. Now we're green. Now we're back on sample. Flow to the analyzer remain basically the same. That is doing exactly what it's supposed to do. As soon as this gets dry, it goes back to reading, exactly the way it's supposed to. It's working perfect. So let's show you how the actual water slip relay tied to the main relay does everything for the solenoid. The solenoid, you're going to set it up just like you would on a valve, just like you would on a valve for an interlock. So in 2, out 1, vent 3. In port 1, out port 2, vent port 3. Same thing as you would do for fail-safe for valves. Got good flow. I hear us gurgling, but it's handling it no problem whatsoever. There's our little note that we put. Here is what's going on inside of there. So typical relay, we're going to bring in a hot that's going to come from the water slip relay. So hot goes out to the water slip relay, comes back in, lands on 7. Whenever the water slip relay gets water on it, it makes the circuit. It'll come in on 7. That'll do the coil, which sucks in the contacts. We'll go from normally closed to the normally open, and we're going to land a hot on 3. That's going to close. That's going to bring our electricity down to 1. We're going to go out on 1, go to our solenoid. Out of our solenoid, we're going to go to neutral. And that's the way all of that looks. I brought in a plug, which we're going to purge this box with nitrogen. It's tubed up to be purged. We are purging. I tubed everything up, so all the contractors will have to do whenever they install this, we can install it, matter of fact, it don't matter, whichever way, is just put one thing of nitrogen, tube it up right there, bring in the 120. I already have this guy here ready for the 120 to come in. Everything is wired up exactly the way I've drawn. If there's any questions, or if anybody has any suggestions on how this could be done better, and don't tell me, make the tubing prettier or anything like that. The hardest part about this was finding washers and stuff like that for all this. We have bolts like crazy, but we don't have any washers. I don't know where, the stand is what I'm super proud of here, because look at this. That was some work. I'm not even kidding. That was some work. I'm going to redo some of the tubing real quick here just because it is ugly. I've had to bend stuff around and move it. And she works, and she works really, really, really good.